Okay, the purpose of this video is to go through two types of calculations. The first one is a type of calculation where you have to work out the percentage dissociation for a weak acid from the pH or the pKa value. And the other type of calculation that we're going to work out is where we go the other way around, where we're given the pH of the acid and we have to work out the Ka value for the acid. Okay, so there are examples of that type of question on page 14 of your OneNote. I'm going to go through the first two questions that are on page 14, and then I'd like you to have a go at doing the other questions that are on that page. Okay, so question 1, first of all, we've been given the Ka value for a weak acid, and the first thing that we have to do is to work out the pKa. Okay, so that first step is quite straightforward. pKa is simply the negative log of the Ka value. So it's going to be the negative log of the Ka value that we're given in the question, and that turns out to be 7.52. Okay, now for part B, this time we've got to work out the pH. Okay, the first thing that I'm going to do is write an equation for the dissociation of this weak acid. Okay, now that I've written the dissociation equation for this weak acid, I can write the Ka expression. Now, to work out the pH, I'm going to have to work out the hydrogen ion concentration. So I've got the Ka value, and I need to work out the hydrogen ion concentration. To be able to work this out, I'm going to draw up an ICE table. From the equation, we can see that for each mole of HOCl that dissociates, we get 1 mole of H plus ions and 1 mole of OCl minus ions. Okay. Now, in the question, we are being told that the concentration of the acid is 0.10 moles per litre. And initially, before any dissociation occurs, the concentration of these two ions is going to be 0. Now, in the process of reaching equilibrium, X moles per litre of the acid are going to dissociate, and we're going to gain X moles of each of these ions. So by the time equilibrium is reached, the concentration of HOCl will be 0.10 minus X, the concentration of hydrogen ions will be X, and the concentration of OCl minus will be X as well. Okay, at this stage, what we're going to do is we're going to assume that because we're talking about a weak acid, which only dissociates to a very small extent, we can safely assume that the value of X is much smaller than 0.1. Okay? Which means that 0.1 minus X is about the same as 0.1. Now we can go back to the Ka expression and we can substitute all of this in there. Okay, so the Ka expression was given to us in the question. It's 3.0 times 10 to the power of minus 8. The concentration of hydrogen ions is X. The concentration of these ions, this ion over here, is also X. And the concentration of the acid is 0.1 minus X, which we decided was close enough to just 0.1. Okay, now solving this equation. And now we can work out the pH, because pH is the negative log of the hydrogen ion concentration. and that works out to be 4.26. The last part of this question is to work out the percentage ionisation. Okay, now the percentage ionisation, that's the concentration of hydrogen ions divided by the concentration of acid times 100. So we just worked out earlier that the concentration of hydrogen ion is 5.5 times 10 to the power of minus 5. The concentration of the acid is given to us in the question is 0.10 times 100, and that gives us an answer of 0.055%. Okay, now on to question 2. This time we've been given the pH of a weak acid and we have to work out the Ka value. Okay, first step, from the pH we can work out the hydrogen ion concentration. So the pH is 3.09. What that means is that the hydrogen ion concentration is going to be 10 to the power of minus pH. So minus 3.09, which gives us a value of 0.00081. Now again, we need to write an equation for the dissociation of this acid and an ice table. So the equation for the dissociation of the acid is as follows. Okay, now if we put together an ice table, it's going to look like this. Initially, the concentration of the acid was 0.05 moles per litre, and the concentration of the two ions is 0. In the process of reaching equilibrium, the concentration of the acid decreases by X, and the concentration of each of the ions increases by X. Okay, now earlier we worked out that the concentration of hydrogen was 0.00081. So X, in other words, must be 0.00081. This is X as well, so it's also 0.00081. And this is 0.05 minus X, so it must be 0.05 minus 0.00081. Okay, now it's just a matter of substituting these values into the Ka expression. So the Ka expression is as follows. So substituting the numbers, we end up with 0.0081 times 0.00081 divided by 0.05 minus 0.00081, and that gives us a value of 1.3 times 10 to the power of minus 5. So that's the Ka value for this particular acid. Okay, now there are a couple of examples that are very similar on the same page of your OneNote, so have a go at those first, and then you've got some slightly different questions at the bottom of the page. Give them a go before our Zoom session, and then we will go through any questions that you might have when we have our Zoom session.